All right, cool, cool. Everything is ready to go. So, any questions from anybody? How's the homework going? Thank you, thank you. I appreciate it. So, how's the homework going? You guys have any questions from the homework you'd like to go over? Okay, no problem. Well, I wouldn't expect you to start, the homework from that was posted last night because we haven't gone over the lesson yet. Well, Tuesday as well. Got you, got you. All right. Tuesdays is actually really, really, really simple. All you have to do is just switch it into the scientific notation, do your division, your multiplication, you know, or or if you have a question where you're just multiplying what's it called? The exponents I meant to say. That's what I'm trying to say. If you're adding, subtracting, multiplying, dividing the exponents, just follow the rules. Particularly the last chart that we had in class that listed all the rules. If you have that open right next to the problem, you'll be good to go. And yes, we go into class on Tuesday as well. All right. So it looks like we have a question here. Um, just bear with me 1 second. This is a good question. Ooh, I gotta count this one right here. So let me see. I have 1, 2, 3. Hold on, you know what? Let me just count it. And I'll do it there. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. 1, 2, 3, 4, 5, 6, 7, 8, 9, and then 69. Got you. And then this is over 0.023. Okay, so long story short, we want to divide these, right? The easiest way to do it, oh, I'm sorry, hold on 1 second. Whoops, there we go. The easiest way to do it, right, will be to change it into scientific notation and then do your division, right? So let's check that out. Let's check that. Oh, sorry about that. Sorry about that. Let's check that out, right? So you know that there's a decimal point right here. I'm just looking at the numerator now, the top number, right? There's a decimal point at the end. I'm going to count how many numbers I have to go before the first number is between 1 and 9. Excuse me, 0 and 10. So I'm including 1 and 9, right? So let's go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, right? So I know that my answer is going to be 6.9 times 10 raised to the 10 power. So this 10 right here is the spaces that I counted over here, right? That's what that is. And now let me do the bottom. So the same thing. I need that first number to be between 0 and 10, or 1 and 9 included, right? So I have a decimal point right here. I'm going to move that over 2 spaces, right? So this is going to become what? 2.3 times 10 to the 1. How many times I moved it? 1, 2. So 10 to the negative 2 power. All right. After you get this far, divide the numbers and then divide the exponents, right? So if I divide these numbers, I have 6.9 divided by 2.3, right? That looks like what? 3, I think. You guys have calculators. Y'all should check me on that, right? Now, this is going to be times 10. Now, remember, whenever I'm dividing exponents, right, I subtract, right? Top minus bottom. That's simple, right? So 10 minus negative 2. And a negative times a negative is a positive. So it's a positive. So my final answer is 3 times 10 to the 12th power. All right. Is there any questions on that? Did that make sense? You can also say 3.0 if you like, but not necessary. 3 is sufficient. But yeah, any questions about that? Is that good, Emil? Awesome, awesome. Yeah, so the hardest part about this is just counting, counting how many times you do in the loop. But once you get the count right, it's over. Yeah. All right, so let's jump into today's lesson if there's no more questions. Okay. Today's gonna be fun. A little easy, but fun. Okay. So here you go. Check this out. So I want you to distribute the 2 onto this binomial term here, right? So essentially, right, what am I asking you to do? Right, I'm asking you to take the 2 and multiply it. That's what I'm asking you to do. Right, so what does this become? 2x plus 6. Right? Is this clear? Does this make sense to everybody? Right? We just distributing, right? Trying to bring it back to a previous idea that we've learned in the past. Distribution. Are we all good? All right, let's keep it moving. Awesome. Thank you. Appreciate the feedback. Ooh, I like this example right here. I like this example right here. Oh, whoops. That's not what I meant to do. Sorry about that. That's not what I meant. Let me try that again. Damn. This is a nice example right here. You guys, help me do this real quick. Help me do this. What's A? You might tell me what the answer for A is.
81.
This is going to be a good one. What's the answer to A right here? This is 9 squared. 9 squared. $81, right? Very good. 81. Now check this out. B. All right, this is about to get interesting. What is negative 9 squared? What do we think?
81. Negative 81?
Negative 9 squared in parentheses. What do we think? What is the answer here? 81. That's what I'm talking about. Right? And why is this one 81? Because a negative times a negative is a positive, and 9 times 9, boom. That's 81. All right, so how about C? What we thinking about? I have negative 9 squared. What do you think? What's the answer to that one? All right. So I heard negative 81. That is excellent. It's exactly what it is, right? Negative 81. And remember, the reason for that is because we have what? Negative 1 times 9 times 9, right? And that's why we get the negative 81. Questions on this? No questions on this? Okay. Ooh, this was a nice homework question right here. Try it out real quick. All right. Let's take a look at this one. The secret here is to just plug it in. So everywhere you see a variable, you put a parentheses. and plug in what they're telling you to plug in. So -2, -2. Doing the math on this, I get 2 times 4 minus 5 minus 2 plus 3. And then I get what? 8 plus 10 plus 3. And then I get what? 18, 21. Questions on that? Any questions on this? We all remember how to do this? Nothing new here, nothing new here.
Got it.
Yep, nothing new here.
Can you hear?
All right, so that was our blast from the past. Let's jump into what we're gonna do now. Hold up, got a little message. Got it. Awesome, awesome, awesome. All right, so that's what we're getting into today, right? We're gonna multiply monomials, right? And we're gonna build on that. So first off, multiplying monomials. We are ready to perform operations on polynomials. Since monomials are algebraic expressions, we can use the properties of exponents to multiply monomials. This is really, really fun. Let's start off with an example. Make that a little bit bigger. Okay, I have 3x squared times -4x to the third power. All right. Real simple, real nice. All right, here we go. All right. So 3x squared times -4x to the third power. So here's what you want to remember when you're multiplying these, right? Numbers with numbers, variables with variables. So 3 times -4 is what? What's 3 times -4? Whoops, sorry about that. What's 3 times -4? -12, excellent, right? And then here's a little bit of a harder question. What is x to the second, right, times x to the third? This would be what? X to the what power? Let's
6.
see.
6.
6, not 6, not 6. What do I do to powers whenever I multiply them? Five. That's it. So whenever we're multiplying exponents, remember that we add, right? So this becomes, sorry about that, 2 plus 3, or, right, 5, right? So this is -12x to the 5 power. That's it. Let me change my color real quick. How about B? All right. Again, numbers with numbers, variables with variables, right? So I got 5/6 times 12. What's that going to be? In my head, I'm thinking 5/6 times 12/1. And then I'm kind of thinking that 6 goes into 6 once, 6 goes into 12 two times, and then 5 times 2 is just 10. Now, what's my variables going to be? X to the what? X to what power? Or tell me how to
The
do it. I'll take that
the
too.
third, would it be the third or the second? Or squared, I mean?
X to the fourth.
So remember, whenever I'm multiplying exponents, I add the
X to the fourth.
powers. So x to the 3 plus x to the 1 is going to be x to the 4. Right? Same thing with the y, right? We're going to add the powers. So 1 plus 2 is 3. Is there any questions on this? Any at all?
Oh, so you're wait, I'm confused
Don't
how
be
you
shy. It's okay to ask a question. No
oh, so you're
penalty.
adding the x to the third power with the 12x, that x, and then you're adding the y from the y. Okay, I see what you're doing. Never mind, I got it.
All right. There's no question. Let me give you guys one to try. I want to be fair. And this is a topic multiplying monomials. Try this out. Try this out. We'll go over it in a minute.
Did I get that wrong? Wait, sir.
Okay. Okay. What are the functions of the plasma membrane? Control entry. It controls what go.
Franklin, that was perfect. Well done.
So I got that right or not? I said minus 35. Y to the 11th power.
So I need help with. I'm not gonna do it because I need help with it. I need him to tell me the steps about this again. I know I do the 15 over one, but then what?
All right, let's take a look. So for A, all right, just tilt that down a little bit. All right, so for A, I want to multiply these two monomials. Now remember, this is what's key, right? Numbers with numbers, variables with variables. So 5 times -7, we know, is going to be -35. And y to the 7 times y to the 4th is going to become y to the 7 plus 4 power, right? So we can just call that, just scroll down a little bit, and call that -35 y to the 11th power. Any questions on that? Okay. Give me 1 second. Let me just change my color. All right, so I'm going to look at B now. All right. So I have 2 over 5, a to the 4th power, b to the 3rd times 15 times a times b to the 3rd, right? Now again, right? Numbers with numbers, variables with variables, right? So I have 2 over 5. I'll just write that here, 2 over 5 times 15, right, over 1. We're going to multiply these, right? Now 5 goes into 5 once, 5 goes into 15 3 times. 2 times 3, what's that? 6. And then we have what? A to the 4th plus 1, right? That's going to give me what? A to the 5th. All right. And then I'm going to have what? B to the 3rd plus 3. This is going to give me B to the 6th. And that's my final answer right there. Is there any questions on this? Any at all? Any questions? Awesome. All right. I'm glad it's making sense. Let's keep it moving then. Let's keep it moving. So a little bit different. A little bit different now. All right. We're just going to take it up a notch. So I want to multiply a polynomial by a monomial. So multiplying a polynomial by a monomial is really just applying the distributive property like we did in our blast from the past earlier. So I'm going to show you guys. Nothing crazy, real nice and simple, real nice and simple. Let me just make that a little bit bigger. Oh, okay. All right, we're good to go. All right. So I feel like doing this in like the rainbow color. So all I'm going to do, right, is I'm going to take this monomial that's on the outside and I'm going to distribute it to all of the terms on the inside. And that's it. That's all we're doing, right? So again, numbers with numbers, variables with variables. So I have -2 times 4. That's going to give me a -8, right? Oh, I'm doing A, by the way. And then we have y to the 1 times y to the second is going to give me y to the third, right? Now, -2 times 3, that's -6. Y to the first times y to the first is going to give me y to the second. And then I have -2 times -5 is going to give me a positive 10, and then y. Did that make sense? Anybody got any questions on that? All I'm doing is I'm distributing the monomial onto the 3 terms of the trinomial.
6, 8, okay.
No questions?
But yeah, I got a question. How would you know what what formula to use? Like, you know how would you tell if it's a polynomial because of the
All
way it's
right, let's
formed
keep it
like this?
moving then.
Hello, you can hear me?
Here's what I want to do, right? Same thing, same thing, same thing. I want to take, hold on 1 second. Hold on 1 second. All right, let's try it again. So I want to take the monomials on the outside and I want to distribute it to every single term that's on the inside, right? So let's take a look. I have 3x cubed times y times x squared. So that's basically 3 times 1, so call that 3. And then x to the third power times x to the second, right? Becomes what? X to the fifth power, because we just add. And then y to the first times 1, basically, is just y. That's our first term. Next, we're going to multiply our second term. So 3 times -8, what is that? -24, right? And then x to the third plus x to the fourth, times x to the first is going to give us x to the fourth. And then we have y times y, which will give us y to the second, right? And then now we want to distribute the 3x cubed y onto the y squared. That's going to give us a positive 3x cubed y cubed. And then that's it. Questions on this, please? Anybody? Any questions? All right, bet. Let's keep moving then. All right. What I want to do is I want to give you guys one to try. I feel like I'm hogging all the fun, but don't give you guys the opportunity to try.
Okay, 3 times 8 is 4. That's 4. Technically, it's 1. So, 4. Okay. X4, right? So that's 3, 4, okay. And then Mhm. Mhm.
All right, let's take a look. Remember, we want to take this whole term, the monomial by itself, distribute it to every single term in the binomial. That's it. So -3 times 5, you already know, -15. And then y times y squared is going to give me a y cubed. Minus negative times positive is negative. 3 times 8. What's that, like 24? And then y to the second. And then a negative times a negative, we know, is a positive. And then 21y. That's A. Any questions on A? Any at all? No questions? All right. No, I can't hear your mic if you're unmuted. So your
Can't hear
mic
me,
is
sir?
probably working. You just have to unmute yourself, and then I'll be able to hear you.
You can hear me?
No. Hold on. Maybe my volume is low. Let me. Nope. I got my
Hello?
volume up. Perfect. I just heard you.
Oh yeah, I just wanted to ask, how would you know like what formula or like if it's a trinomial, monomial, or polynomial? Like how would
So
you know?
got you. So when you hear me say trinomial, I'm counting the number of terms that are here. So it's like one term, two terms, three terms. So trinomial,
So
right?
that's a trinomial right there. Okay.
Right. In the parentheses, a trinomial. And by itself on the outside right here, that's a monomial.
Okay.
Yeah. So
So
all
the
I'm
outside of the parentheses is the binomial.
monomial, yeah. So that
Okay.
means one term. One
All
term.
right.
Yeah. So all I'm doing is I'm taking the term and I'm just distributing it just like that.
I'm lost. Um,
Go
mm.
ahead.
So where did you get the you see how you put negative? I know how you got the negative 15, but why is it y3?
Why is it 3y?
No, you see, I know the y is next to the 15, but how did you get to the third power?
Oh, I got you. So this is, for example, negative 3y times 5y squared, right?
Mhm.
So the numbers would be negative 3 times 5, that's a negative 15.
Right, I got
And then
that.
the variables is y times y squared. Now remember, whenever we multiply exponents, we add them. So this becomes y to the 1 plus 2 power.
Got it. Okay, so that's where all right, got it. That's
Yeah,
what all right, got it.
yeah. So for B, I'm gonna do the same thing kind of, right? I'm gonna do the same thing kind of in B. So numbers with numbers, variables with variables. All right, 1 second. Awesome. Numbers with numbers, variables with variables. So 4 times 3, that's gonna give me a 12. Oh, sorry about that. That's gonna give me a 12, right? And then x squared times x squared is gonna give me x to the fourth power. Remember, just adding them, 2 plus 2, 4. And then I have y to the second. And then I'm gonna have negative 5 times 4 is gonna give me a negative 20. And I'm gonna have x to the third, y to the third. And last but not least, I kind of ran out of space a little bit, so I'm just gonna pull this to the side, right? So I'm gonna have positive, right? 3 times 4, what's that? 12. Then I'm gonna have, hold on 1 second. Let's go to the side. Then I'm gonna have x squared, and then y to the fourth power. Any questions on this one? I'm just distributing here, right? Numbers with numbers, variables with variables. Any questions on this? Nope. All right. Let's keep it moving then. Let's keep it moving. So I'm gonna change it up just a little bit, but this is gonna look very familiar to a lot of you. Very, very familiar to a lot of you. So check this out, check this out. I want to multiply a binomial by a binomial, right? So just like there are different ways to respect multiplication of numbers, there are several methods that can be used to multiply a binomial times a binomial. We start by using a distributive property. So check this out. All right, let me give y'all an example real quick. And I know a lot of y'all gonna remember this, right? Boom. So I have y plus 5 times y plus 8, right? So you guys probably remember the FOIL method. We have the first, we have the outer, we have the inner, and then we have the last, right? Everybody remembers that FOIL method, right? That's what we're doing here. Nice and simple. So y times y squared. Y times 8 plus 8y. 5 times y plus 5y. 5 times 8 is going to be plus 40. And then when I'm done with that, I want to combine like terms. I have the 8y plus the 5y. This is going to become what? Y squared plus, what's this? 13y plus 40. Then that'll be my final answer, combining like terms. Questions on this? I feel like we might remember doing this. FOIL method. Same thing as a distributive method. All right, there's no questions. Let's keep it moving. Let's keep it moving. I want something nice. Let me try this one. All right, same thing, right? We're gonna do this one first, right? So 4y times 2y is gonna give me what? 8y squared. Then I'm gonna do 4y times -5 is gonna give me a negative 20y. Then I'm gonna do 3 times 2y, which is gonna give me a positive 6y. And then last but not least, I'm gonna do 3 times -5, which is gonna give me a negative 15. But I'm not done, right? I want to combine like terms. So what am I left with? 8y squared, right? Minus, and then what's this? Negative 14y minus 15. This is my final answer. Is there any questions on this? Any at all? This makes sense? Any questions? All right, cool. So let's try one. Give me 1 second. I'll give you guys one to try on your own. Like I was saying, I don't like to hog all the fun for myself. Even though you guys do have homework, try that out. Same thing, right? Just foil it out and you're good to go. Let me do this so you guys can see process right there. Go ahead, try that out real quick. Take a minute, try those. All right, let's take a look. All right, same game as before. All right, we're just foiling this, right? So x times x is going to give me x squared. X times 9 is going to give me 9x. 8 times x is going to give me 8x. And last but not least, 8 times 9 is going to give me, what is that? 9 is 18, 36. What's that, 72? Check me on that. Y'all got calculators. Check me on that, right? And then we going to combine like terms here. What do I get? I got x squared plus, what's that, 17x plus 72. Everybody got that answer? Any questions on that? All right, sounds good, sounds good. Let me keep it moving, let me keep it moving. So I have a 3c plus 4 times 5c minus 2, right? I'm gonna do the same thing, 3c times 5c. What's that gonna be? That's gonna be 15c squared. Then 3c times negative 2, that's gonna be what? Negative 6c. Then 4 times 5c is gonna be plus 20c. And then last, 4 times negative 2 is gonna give me a negative 8. After that, I want to combine like terms, right? Combine like terms, a fancy way of saying add. So I'm going to get 15c squared, right? Plus, and then 20 minus 6, what's that, 14? C minus 8. And then this will be my final answer. All right. Any questions on this? Go ahead. Any questions? All right. Sounds like this is good. Let's keep it moving. All right. Just give y'all a little bit of notes real quick before we jump into another example. All right. So if you multiply binomials often enough, you may notice a pattern. Notice that the first term in the result is the product of the first term in each binomial. The second and third terms are products of multiplying the two outer terms and then the two inner terms. And the last term results from multiplying the last term, the two last terms, excuse me, right? So give you guys a little bit of a visual example of what I'm hinting at, right? So Lord, sorry about that. 1 second, you guys. Sorry about that. Okay, so we abbreviate first, outer, inner, last as FOIL. The letter stands for first, outer, inner, last. We use this as another method of multiplying binomials. The word FOIL is easy to remember and ensures we find all four products. Let's multiply x plus 3 times x plus 7 using both methods. So for the distributive property, I would take the x plus 3 times x plus 7. I would split the x plus 3 apart, right? And just multiply that, and then multiply the x plus 7 times each part. So this would be x times x plus 7 plus 3 times x plus 7, right? Distribute those, combine like terms, boom, I get the answer. However, the method that we were using, the easier method, is the FOIL. You do the first term, second term, the inner, and then the last, right? And then you just combine like terms. So we summarize the steps of the FOIL method below. The FOIL method only applies to multiplying binomials. That's key, right? This is only for multiplying binomials, not other polynomials. So other polynomials, you have to use the distributive property, right?
I canceled it out.
Okay. Let me just give you guys some notes real quick. Little how-to. I hope this helps. Just want to make it like clear for you guys. So how to use the for method to multiply two binomials. Step one, multiply the first terms together, right? So first terms being the first and the first, right? Step two, multiply the outer terms, right? So it's gonna be the first and the last, right? Step three, multiply the inner terms, right? So that's gonna be like the B and the C right here. And then step four, multiply the last terms, right? So that's gonna be like the B and the D right there, right? And then you combine the like terms when possible, right? So say it as you multiply FOIL first, outer, inner, last. All right. You guys can copy that down. All right, just give me a little how to. All right.
What? I pulled back. I pulled out. But you know what I'm
You
saying?
hold up 1 second.
Real men don't pull out. Nickel is.
Got you. So when you multiply by the FOIL method, drawing the lines will help your brain focus on the pattern and make it easier to apply. Right now, we'll do an example where we use a FOIL pattern for two binomials, similar to what we just did before, just more practice. All right. All right. Nothing crazy here. Same thing that we've been doing before, right? I'm going to multiply the y times y. That's going to give me what? Y squared. Then I'm going to multiply the y times a positive 4. That's going to be what? Positive 4y. Then I'm going to multiply the negative 7 times y. That's going to give me negative 7y. And then last, I'm going to multiply the negative 7 times 4, which is going to give me, oh boy, that's going to give me a negative, what is that, 7, 7 is 14, 28. And then after that, you want to combine like terms, right? Combine like terms. So now I'm going to get y squared minus, right? This is going to be 3y minus 28. And there you go. That's my final answer. All right? Questions on this? Or does it make sense? All right, I'm just taking y'all silence as a understanding, and you guys know. All right, let me just switch this up real quick. We'll try that crimson right there, right? All right, so I'm looking at B now, right? Same thing. So I want to multiply, right? The two first. So 4x times 2x is going to give me an 8x squared. After that, what do I want to do? I want to multiply the 4x times the negative 5. This is going to give me what? A negative 20x. And then next, I want to do a 3 times 2x is going to give me what? A positive 6x. And last but not least, I'm going to do a 3 times negative 5, which is going to give me a negative 15. After that, what do I want to do? I want to combine like terms, right? This is going to give me what? 8x squared, right? And then this is going to be a negative 14x when I combine like terms. Bring down that minus 15, and then this will be my final answer here. Any questions on that? Anybody? All right. Well, that sounds good. That sounds good. So let me give you guys one to try. Again, I'm just trying to make sure that it's clear. Just trying to make sure that it's clear. You guys will have this on your homework, so you will get even more opportunities to practice this. All right. All right. Let's take a look. Again, this is the same process as before, right? I'm just gonna multiply my first. X times x is x squared. Multiply my outer. X times 5, this is plus 5x. Multiply my inner. This is going to be negative 7x. And then last but not least, multiply my last. Negative 7 times 5, that's going to give me a negative 35. Let's combine like terms. I'm going to have x squared minus 2x minus 35. Everybody got that?
Yes.
Awesome, awesome, awesome. Love that. All right, let's keep it moving. I'm gonna multiply my first term. This is 3x times 5x, which is gonna give me a 15x squared, right? Then I'm gonna do a 3x times a negative 2x, which is gonna give me a negative 6x, right? Sorry. Then I wanna do a 7 times 5x, which is gonna give me a positive 35x. And then last but not least, I wanna do a 7 times negative 2, which is gonna give me a negative 14. After that, I want to combine like terms. When I combine like terms, I have 15x squared, right? Plus, right? This is going to be 29. Oops, excuse me, 29x minus 14. And that's going to be my final answer. Questions on this? Anybody? Any questions? All right, sounds good. Let's keep it moving. Let's keep it moving. So I'm going to give you guys a special note real quick before we jump into the next example. All right, the final products in the last example were trinomials because we could combine the two middle terms. But this is not always the case, right? Let's take a look at what I'm talking about. Let's take a look. Now, nothing's changing in these problems, right? I'm going to use the same procedure that I used before. Nothing's changing, right? But let's look at what happens. So I'm going to distribute this, right? So I have n squared times n. That's going to give me a n to the third power, right? Next, I have n squared times negative 1. It's going to give me a negative n squared. Then I'm going to have 4 times n, which is going to give me a positive 4n. And then I have positive 4 times negative 1, which is going to give me a negative 4. However, now when I go to combine like terms, there are no like terms here. So this is all I could do. This is my final answer. That's it. All right. Let's take a look at that again. Let's look at this other example. So I have 3PQ, right? 3PQ. I'm going to multiply that by 6PQ. What's that going to be? That's going to be, let me think. 6 and 6 is 12, 6 and 7, 18. So this is going to be 18. Hold on. I'm getting carried away real quick. Let me switch up my pen color. Let's try that again. So that's going to be 18 P squared Q squared, right? And then now I'm going to do 3PQ times negative 11, which is going to give me a negative 33 PQ. Just pull this to the side real quick. All right, that's looking good. That's looking good. Let's move this up here. All right. Next, I'm going to have 5 times 6 PQ, which is going to give me a positive 30 PQ. And then last but not least, I'm going to have 5 times negative 11, which is going to give me a negative 55. Combining like terms, I'm going to get what? 18. Whoops. 18 P squared Q squared minus 3 PQ minus 55. this will be my final answer. Because in this situation, I can combine like terms. Is there any questions on this from anybody? All right. You guys try. Put it out. All right, let's take a look. All right, I'm using the same technique as before. Nothing's changing, right? We're about to FOIL this. Bam. All right. So I have x squared times x is going to give me x cubed. Next, I'm going to do x squared times -8. That's going to give me a -8x squared. After that, I'm going to have 6 times x, which is going to give me a positive 6x. And last but not least, I'm going to have 6 times -8, which is what? 12, 24. That's about -48, right? However, I have no like terms in this. So this is my final answer. Questions on this? All right, no questions. Let's keep it moving. I'm gonna have 2ab times 4ab, which is gonna give me what? 8a squared b squared. After that, I'm gonna have 2ab times -4. Now positive times a negative is a negative, and 4 times 2 is 8, and then we're just gonna have our ab. Next, I'm gonna have 5 times 4ab, which is gonna give me a plus 20ab. And last but not least, 5 times -4 is going to give me a -20. After that, I want to combine like terms, right? Combine like terms. So I'm going to have 8a squared b squared, right? Plus, what's this going to be? 12ab minus 20. And this is my final answer right here. Is there any questions on this? Is it clear? Does it make sense?
Yeah, got it.
Okay. Let's keep it moving then. Let's keep it moving. So we're gonna take it up a notch. I'm gonna take it up a notch. All right. I'm gonna multiply a polynomial by a polynomial. So we've multiplied monomials by monomials, monomials by polynomials, and binomials by binomials. Now we're ready to multiply a polynomial by a polynomial. Remember, FOIL will not work in this case, but we can use either the distributive property or the vertical method. Don't worry about the vertical method. We're just going to focus on the distributive property, right? Works for everything. We love that. Let's take a look. Let's take a look, right? Show you what I'm talking about. I'm going to start off simple. So I have b plus 3 times 2b squared minus 5b plus 8. So that is a binomial times a trinomial, or a polynomial by a polynomial. It's the same method, the same thing we're going to do. Nothing's changing. So I'm going to have the b times 2b squared, right? That's going to give me 2b cubed. Next, I'm going to have b times -5b, which is going to give me a -5b squared. Next, I'm going to have b times 8. This is going to give me a plus 8b. Now we're going to do the second term, right? I'm going to have 3 times 2b, which is going to give me a positive 2b squared. Ooh, nobody even said nothing. That's going to give me a positive 6b squared, right? Then I'm going to have my 3 times -5b, which is going to give me a -15b. And then last but not least, I'm going to have my 3 times 8, right? Which is going to be what? That's going to be, I think, positive 24, right? Now, let's combine like terms. Combine like terms. So I have the 2b cubed. Now, this is a personal preference of mine. Every time I write down one, I like to kind of cross it out. Next, I'm going to combine I'm going to look at my squares. So I have negative 5b squared plus 6b squared. That's just going to give me a plus b squared. Plus b squared. These will cancel out. Now I have 8b minus 15b. That's going to give me what? I think 7b. So negative 7b, right? And then, of course, we just have the positive 24, excuse me. So we're just going to write that down, right? This is my final answer. Questions on this? Anybody? This makes sense? All right, let's keep it moving then. Let's keep it moving. You guys try? Try it out, try it out. All right, let's take a look. And change this up real quick. All right, we're doing the same thing as before, right? Nothing's changing. Gonna distribute this first term, y times y squared. It's gonna give me y cubed. Then I'm gonna have y times negative 5y. It's gonna give me a negative 5y squared. After that, y times 2. This is gonna give me a positive 2y. Then I'm gonna have negative 3 times y squared. This is gonna give me a negative 3y squared. I'm sorry, let me just move this 1 second. Okay. Next, I'm gonna have negative 3 times negative 5y, which is gonna give me a positive 15y. And last but not least, I'm gonna have negative 3 times 2, which is gonna give me a negative 6. After that, I wanna combine like terms. This is gonna give me y cubed, right? And then 5, 6, 7, 8, this is gonna be a negative 8y squared. And then plus 17y, right? And then minus 6. And then this will be my final answer because there's nothing else that I can combine like terms with. Questions on that? Everybody got that? All right. Sounds good, sounds good, sounds good. So that was multiplying a polynomial by a polynomial. Now we got to talk about something else. Still related. We're still multiplying polynomials by polynomials, but I want to talk about some special products. All right. Talk about some special products. So mathematicians like to look for patterns that will make their work easier. A good example of this is squaring binomials. While you can always get the product by writing the binomial twice and multiplying them, there is less work to do if you learn to use a pattern. Let's start by looking at 3 examples and look for a pattern. So look at these results. Do you see the pattern? So I have x plus 9 squared, right? Which is the same thing as x plus 9 times x plus 9, right? And then when I FOIL it, I get x squared plus 9x plus 9x plus 81. And then that gives me x squared plus 18x plus 81. Let's say I have y minus 7 squared, which we know is the same thing as y minus 7 times y minus 7. FOIL it, and I get y squared minus 7y minus 7y plus 49. Combine like terms, I get y squared minus 14y plus 49. Last but not least, I have 2x plus 3 squared, which we know is the same thing as 2x plus 3 times 2x plus 3. Foiling it, we get 4x squared plus 6x plus 6x plus 9. Combining like terms, we get 4x squared plus 12x plus 9. What about the number terms? In each example, we squared a binomial and the result was a trinomial, right? Here we go here. So now we look at the first term in each result. Where did it come from? The first term is the product of the first term of each binomial. Since the binomials are identical, it is just the square of the first term. So a plus b squared is equal to a squared. To get the first term of the product, square the first term. Where did the last term come from? Look at the examples and find the pattern. The last term is the product of the last terms, which is the square of the last term. So b squared is the last term, right? And then to get the last term of the product, right, you square the last term. Finally, look at the middle term. Notice it came from adding the outer and the inner terms. which are both the same. So the middle term is double the product of the two terms of the binomial, right? So for a plus b squared, you get positive 2 times ab, and for a minus b squared, you get negative 2ab. All right. So to get the middle term of the product, multiply the terms and double their product. Put it all together. Let's look at what we have. Let's look at what we have. All right. It's our shortcut, right? So we have the binomial squares pattern. If a and b are real numbers, then a plus b squared is equal to a squared plus 2ab plus b squared, where a plus b squared is a binomial squared. The first term is a squared plus 2 times the product of the term, so 2 times a times b, plus b squared, which is the product of the last term. Similarly, if I have a minus b squared, then I get a squared minus 2ab plus b squared, where a minus b squared is a binomial squared. The first term will be a squared, right? And then minus 2ab, the product of the two terms, and then plus b squared, which is the last term squared. So the square, to square a binomial, square the first term, square the last term, and double their product in the middle, right? That's the shortcut. So let's take a look at this. So real quick, I know Lewis and Rainbow. I know that a plus b squared, right, is equal to a squared plus 2ab plus b squared, right? I want to know what is x plus 5 squared, right? So for a, what do I have? I have x, just going to square that, plus 2 times, what's a? X, and what's b? 5, plus, what's b again? 5, and then squared. Doing the math on this, what do I get? X squared plus 10x plus 25. And that's my final answer there. Questions on that? No questions? All right. Look at that next one real quick. So I know that a minus b squared is equal to a squared minus 2ab plus b squared, right? In my case, what do I have? I have 2x minus 3y. So I have 2x minus 3y squared, right? Which is going to give me what? For a, I have 2x squared minus 2 times, what's a? 2x. What's b? Negative 3y, right? Plus b squared, which is what? Negative 3y squared, right? Actually, this should be just plain 3y. I'm sorry about that, right? Now, let's do the math on it. Nothing crazy. This becomes what? 4x squared minus, let me see. 2 times 2 is 4. 4 times 3. What's that? 12. XY. And then plus 9y squared. That's it. This will be my final answer. Questions on this? Anybody? Just plugging it in to the formula. You guys try. Sorry about that. Take a look. So I want to use the pattern here, right? The pattern is kind of like a shortcut, right? Kind of like a shortcut. No problem, no problem. All right. So, sorry. I have x plus 9 squared. We're going to use a shortcut, right? So we have a squared, which is going to be the x squared, plus 2 times the a times the b, plus the b squared. Doing the math, what do I get? X squared plus 18x plus 81. That's using the shortcut. That's the answer. Questions? All right. Next one, I have 2c minus d. All right. So I want to use a shortcut. So that's going to be a squared, which is 2c squared, minus 2 times a, which is 2c, times d, which is d, plus, right? This is going to be the d squared. Let's do the math on this real quick. This is going to be 4c squared minus 4cd plus d squared. And that's that. Did everybody get that answer? Any questions on that? All right. If there's no questions. All right, we just saw a pattern for squaring binomials that we can use to make multiplying some binomials easier. Similarly, there's a pattern for another product of binomials, but before we can get to it, we need to introduce some vocabulary. A pair of binomials that each has the same term and the same last term, but one is a sum and one is a difference is called a conjugate pair. And it is often of the form a minus b times a plus b. Real quick. So conjugate pair, right? So a conjugate pair is two binomials of the form a minus b times a plus b, right? The pair of binomials each have the same first term and the same last term, but one binomial is a sum and the other one is a difference. Okay? So there is a nice pattern for finding a product of conjugates. You could, of course, simply FOIL to get the product, but using the pattern makes the work easier. Let's look at the pattern of FOIL to multiply some conjugate pairs. So I have x plus 9 times x minus 9, right? It's going to give me x squared minus 9x plus 9x minus 81. Combine like terms, we get x squared minus 81, right? And so on and so forth, right? You're going to multiply them. The only difference between them is that one has a 1 and the other one has 5 or whatever, right? So what's going to happen here? There's a pattern here. What do you observe? The product of the two binomials is also a binomial. Most of the products resulting from the FOIL have been trinomials. Each first term is a product of the first term of the binomial, and since they are identical, it is a square of the first term. So a plus b times a minus b is going to be equal to a squared. To get the first term, square the first term. The last term came from multiplying the last terms, the square of the last term. So to get the last term, square the last term. That's it. That is it. So why is there no middle term? Notice that the two middle terms you get from FOIL combine to 0 in every case, the result of one addition and one subtraction. The product of conjugates is always of the form a squared minus b squared. This is called the difference of squares, right? And that leads us to the pattern. And we have the product of conjugate patterns. If a and b are real numbers, right? A minus b times a plus b will be a squared minus b squared. So conjugates a minus b, a plus b, right? Difference or square, a squared minus b squared. The product is called a difference of squares. To multiply conjugates, square the first term, square the last term, write it as a whole, as a difference of squares. So we want to multiply using the product of conjugates pattern. So I have 2x plus 5 times 2x minus 5. What's going to happen? I'm going to have 2x squared minus the 5 squared. Call it a day. This is what? 4x squared minus 25. That's it. Let's look at B. So for B, same thing. I have 5m minus 9m and I have 5m plus 9m, right? So I'm going to do a squared, which is 5m. Simplify this down. What do I have? 25m squared minus 81n squared. Questions on this? Anybody? You guys try. Awesome. I'm glad it makes sense. Let's look at A. I'm going to use the shortcut. I have 6x plus 5 and 6x minus 5. First term is going to be 6x squared. Minus the second term, which will be 5 squared. Doing the math on this, what do I get? I get 36x squared minus 25. All right. Questions on that? All right, let's keep it moving. I'm going to use a shortcut for B. So I have 4p squared minus 7q squared. Doing the math on this, I have 16p squared minus 49. 49q squared. Questions on this? Anybody? We just developed special product patterns for binomial squares and for the product of conjugates. The products look similar, so it is important to recognize when it is appropriate to use each of these patterns and to notice how they differ. So look at the two patterns together and notice their similarities and differences. All right, let's look at them together. So we want to compare the special product pattern. So we have the binomial squares. So you already know a plus b squared is going to be a squared plus 2ab plus b squared. For a minus b squared, we're going to have a squared minus 2ab plus b squared, right? Squaring a binomial, product is a trinomial, inner and outer terms with FOIL with FOIL are the same. The middle term is double the product of the terms, right? Multiplying conjugates, multiply the conjugate, product is a binomial. Inner and outer terms with FOIL are opposites, and there's no middle term. Okay. Now, when it comes to these special patterns, you don't have to remember these tricky formulas if you don't want to. You can simply just distribute and combine like terms, and you will always get the question right, no matter what. Always, always, always. All right. All right, I think we're good for multiplying polynomials. So I want to get into another topic similar to this. Well, first, I want to do a little blast from the past. Somebody tell me what the answer to this is. So why is it still squared? Hold on. Because 25, excuse me, the 25 doesn't have a square on it because 5 times 5 is 25. That's why it's like that. Sorry about that. Just saw the message right now. So long story short here, right? I have 3 over d plus x over d. I have the same denominator, which is what I want. And because I have the same denominator, right? I can add these together. So this becomes what? 3 plus x all over d. And then that's it. Simple, simple, simple. Little blast from the past. So here I want to simplify 30xy cubed over 5xy. What I'm going to do is the numbers first. So 30 divided by 5 is 6. Right? And now x and x will cancel out. Y to the cube and y will cancel out, leaving x squared. So this is 6 y squared. Over here, so combine alike terms. So let's look at what we have alike here. 8a squared plus 3a squared. That's going to give me what? 10, 11 a squared. Next, I have 12a negative 5a. It's going to give me what? Positive 7a. And then last but not least, 1 plus 4 plus 5. All we're doing here is just combining like terms of multiplication. We're just adding. All right, similar to our last topic, I want to divide monomials. So now we'll see, we are now familiar with all the properties of exponents and use them to multiply polynomials. Next, we'll use these same properties to divide monomials and polynomials. Check it out. This question here says find the quotient, right? So let's look at what I have. I have 54 a squared b cubed divided by negative 6 ab to the 5th. Now a positive divided by a negative is a negative. 54 divided by 6. Oh boy, what is that? I think it's 9, right? Yeah, this is just 9. And then a on the bottom, a squared will cancel out, leaving back just a, right? Over. And then we're going to have b to the second. Question on this. B to the second came from 3 minus 5, which will give me a -2. So what do? Throw it in the denominator, give it a positive exponent, and that's it. Any questions on this? All right, since we have no questions. I'll let you guys try one. Just divide them the way you know how to, right? Numbers with numbers, variables with variables. All right, let's take a look. So I have -72, a to the 7, b to the 3rd, over 8, a to the 12, b to the 4, all right? Now we know a negative divided by a positive is going to be negative, right? And then 72 divided by 8, let me think, what is that? That's yep, that's 9, right? So -9. And then we're gonna divide the top by the bottom. So a to the 7 divided by a to the 12. You already know that's a to the 7 minus 12. And then we're gonna have b to the top, which is a 3, minus the bottom, which is 4. This is gonna give me -9, a to the negative, what is that? It's 5. And b to the -1. But you know it's illegal for me to have negative exponents, so final answer, -9 over a to the 5th, b. And that's that. Any questions on this? Anybody? All right, let's keep it moving. Let's keep it moving. Sorry about that. So once you become familiar with the process and have practiced it step by step several times, you may be able to simplify a fraction in one step, right? Let's look at this other example here. So I have 14 x squared y to the 12 divided by 21 x to the 11 y to the 6, right? So what they mean by one step is we just jump straight to the numbers, right? Like I know that 7 goes into 14 what, 2 times, and 7 goes into 21 3 times. So I know I'm gonna have a 2 over 3, and then we have x to the 7, right? X to the 11, which you know is gonna become x to the 7 minus 11, which will be x to the negative, what's that, 4, right? So drop that in the denominator, make that positive, x to the 4. And then y to the 12 divided by y to the 6 becomes just y to the 6, right? 12 minus 6 is 6, done. This is what they mean by one step, right? Questions on this? Feel like I overloaded Excel a little bit. Give me 1 second real quick. It's coming back, it's coming back, it's coming back. I might have overloaded Excel a little bit. All right, we good to go, we good to go. Sorry about that. Sorry about that, let me bring that back. All right. So that's it. Whoops. That'll be it. All right. You guys might want to try one. Here's one for you to try. Try this out. So I got 2849. Right? Looking at this, 7 can go into 28, right? That goes in what, 4 times? The 7 can go into 49, I think 7 times. So right there, I know I have 4 over 7. X to the 5 minus x to the 9. Oh, excuse me, x to the 5 divided by x to the 9 becomes x to the 5 minus 9 power. Call that -4, throw that in the denominator, x to the 4. Then we're going to have y to the 14 divided by y to the 12. That's just going to become y to the 2nd. And this will be my final answer. Questions on this? All right, let's keep it moving. So now we want to divide a polynomial by a monomial, right? Now that we know how to divide a monomial by a monomial, the next procedure is to divide a polynomial of 2 or more terms by a monomial. The method we'll use to divide a polynomial by a monomial is based on the property of fraction addition. So we'll start with an example to review fraction addition. The sum of y over 5 plus 2 over y simplifies to y plus 2 over just plain 5. Now we will do this in reverse to split a single fraction into separate fractions. For example, y plus 2 over 5 can be written as y over 2, excuse me, y over 5 plus 2 over 5, right? This is the reverse of fraction addition, and it states that if a, b, and c are numbers where c does not equal 0, then a plus b over c is equal to a over c plus b over c, and we will use this to divide polynomials by monomials. So this is the secret right here. This is the sauce. All right. So division of a polynomial by a monomial. So to divide a polynomial by a monomial, divide each term of the polynomial by the monomial. Let's take a look at an example. So I want to find a quotient of this, right? So I have 18 x cubed y minus 36 xy squared divided by -3xy, right? So what I'm saying is take each term at the top and put the division beneath it. All right. And then we're going to do the same thing on the other side. So plus, we're going to have -36 xy squared over -3xy. And let's see what happens. Now, a positive divided by a negative, we know is a negative. 18 divided by 3, what's that? That's about 6, right? And then x to the third divided by x is going to give me x to the second, and y's will cancel out. This will be my part of my answer. Plus, a negative divided by a negative is a positive. 36 divided by 3, what's that? 12. X's cancels, y will cancel, leaving back just y to the 1 power. And this will be my final answer. Questions on that? Whoops. So why is the y and the x not on both sides of the fraction? It is, no? Negative, hold on. Negative 3xy, negative 3xy. They're on both sides of the fraction. And then you just reduce the fraction. That's the hard part. You gotta actually divide it and reduce it. All right. You guys try. All right, let's try it out. So I have a 32 a squared b over the negative 8ab plus a negative 16ab squared divided by a negative 8ab. Divide them out. 32 divided by negative 8, a positive divided by a negative is a negative, and 32 divided by 8 is, I believe it's 4, right? Yep. So that's like 4. A squared divided by a is just a. B's cancel out. Next, a negative divided by a negative is a positive. 16 divided by 8 sounds like 2. A, and then the b's will cancel out, even back just b on the top. And that's it. Questions on this? So separate them, divide them out the way you normally would, and then that's it. Okay. This is going to be our last topic. Hopefully I have time to let you guys try one, but if not, I'll at least run through the process and you'll be able to do your homework. All right. So this is called dividing polynomials using long division. All right. This will work for everything. Dividing a polynomial by a binomial, we follow a procedure very similar to long division of numbers. So let's look carefully the steps and we take when we divide a 3-digit number 875 by a 2-digit number 25. So first off, 25 goes into 87 3 times, right? So we write the 3 on top where the quotient is. Then we're gonna do 3 times 75. Excuse me, 3 times 25, which is 75, right? And we subtracted 87 minus 75 is 12. Bring down that 5. Now we have 125. And 25 goes into 125 5 times, and 5 times 25 is 125. Subtract that, that's 0 as your remainder. So we check division by multiplying the quotient by the divisor. If we did the division correctly, the product should equal the dividend. So 35 times 25 is 875. Now we will divide a trinomial by a binomial. As you read through the example, notice how similar the steps are to the numericals above. All right. This right here is going to help you out. So I have x squared plus 9x plus 20 divided by x plus 5. So here's how we do this, right? So I'm going to put my divisor right? On the outside, so x plus 5. On the inside, my numerator, which is x squared plus 9x plus 20. And then very simply, x goes into x squared how many times? X times. And x times x is x squared. X times 5x is plus 5x. And then I want to subtract these. But remember that this is a polynomial, right? So x squared minus x squared will cancel out. 9x minus 5x is 4x. After that, bring down your positive 20. Now x goes into 4x plus 4 times, and 4 times x is 4x. And 4 times 5, 20. When you subtract these out, you get 0. So my answer, my answer is the quotient, which is this, x plus 4. This is my divisor. Over here. This is my remainder. All right? And that's it. That's the long division right there. I think we have like 3 minutes. I would love for you to try one. Let me see if there's anything else extra to say. I think I feel good about wrapping it up right there, but let me just give you guys a little bit of notes real quick. A little bit of notes. This is going to be real quick. Okay. So when we divide 875 by 25, we had no remainder, but sometimes division of numbers does leave a remainder. The same is true when we divide polynomials, right? So in the next example, we'll have a division that leaves a remainder. We write the remainder as a fraction with the divisor as a denominator, right? So look back at the dividends in previous examples, and terms were written in descending orders of degrees, and there were no missing degrees. The dividend in this example will be x to the 4 minus x to the second plus 5x minus 6. It is missing a x to the third term, right? We will add in the 0x cubed as a placeholder, right? Got you. So we should really take a look at this next example. And then after that, we can wrap that up. I think you guys will have more than enough knowledge to do the rest by looking at this one example. All right. So here's the situation I have now. I have x to the 4th, right? Let me write that out. X to the 4th minus x squared plus 5x minus 6, all divided by x plus 2. Now, it's the same type of division we're going to do, right? Our divisor goes on the outside, x plus 2, boom, right? And then I'm going to write in our numerator. So I have x to the 4th, but notice I don't have an x to the 3rd term, so I'm going to add that in. So plus 0, x to the 3rd, minus x to the 2nd, plus 5x minus 6. Long division now, right? X goes into x to the 4th how many times? X to the 3rd times. And x to the 3rd times x is x to the 4th. And x to the 3rd times 2 is going to give me a positive 2x cubed. After that, you're going to subtract this out. When I subtract this, remember it's a polynomial. X to the 4th will cross out. 0 minus 2x squared is going to give me a negative 2x cubed. Excuse me, x cubed I meant to say. Bring down your negative x squared. Now, x goes into negative 2x cubed, right? Negative 2x squared times. Negative 2x squared times. Negative 2x squared times x is going to give me a negative 2x cubed. Negative 2x squared times 2 is going to give me a negative 4x squared. Remember, these are polynomials, so I'm going to subtract these. So now, what am I left with? These cancel out. Negative x squared minus a negative 4x squared is going to give me a what? A positive, right? Positive, right? 3x squared. Now we want to bring down that positive 5x. Now x goes into 3x squared plus 3x times. So 3x times x is going to give me a 3x squared. And then 3x times 2 is going to give me a positive 6x. I'm going to subtract these. Right? Now the 3x squared and the 3x squared will cancel out. 5x minus 6x is going to give me a negative 1x. And then I want to bring down that negative 6. Now x goes into negative x, negative 1 times. And negative 1 times x is going to give me negative x minus 2. And then remember, this is a polynomial, right? So I want to subtract this. So now what do I have? The negative x's will cancel out. Negative 6 minus negative 2 is going to give me a negative 4, right? So let's check this out. My quotient is up here. My divisor is over here, right? And my remainder is over here. Now, sometimes they might ask you to write out your answer where you have the quotient real big and nice, x cubed minus 2x squared plus 3x minus 1, with the remainder, right? The remainder, here's our remainder, 4, over the divisor. It's our divisor, x plus 2. Sometimes they might ask you to write it out like that. Kind of similar to how we did mixed numbers. You remember a mixed number when you have 2 and like 3/4, for example? Same idea here. The 2 would be the quotient, you know, and then you have your numerator and you have your denominator. Same thing. All right? So just want you guys to be aware of that. Your homework is probably going to ask you like, oh, what's the quotient? Boom, type it in. Oh, what's the remainder? Boom, type it in. You know, oh, what's the divisor? Boom, type it in. And that's it. All right? Do your best. Try your homework, and then we'll catch up. All right? Talk to y'all soon. Have a great night, everyone. I am going to tutoring. I'll be there at 5 online. If anybody wants to join, make the appointment and come through. Remember that tutoring is also open on the weekend, right? Tomorrow's what, Friday? So from 12 to 6 and Saturday 12 to 6, you guys are welcome to come either in person or online, your choice, no pressure. All right? Try to stay on top of the homework. All are welcome. All right? And it's been a great day with you guys. All right? And I'll see you guys later. All right? Have a great night, everyone. Great night. All right? And also give me a little bit of time, maybe about an hour or so, and then I'll get this posted for you. All right? Have a great night.